You were the flight director for NASA's Mars exploration rovers and the Phoenix Mars lander, so you're thoroughly embedded in that community, but now you've broken out into the entrepreneurial horizon, or horizonless, nature of space.
Absolutely.
So how's it going?
It is an amazing adventure, I think is what I would describe it as. Certainly doing the amazing things that NASA does, it was very privileged to be a part of a fantastic team who put 2 rovers on Mars and a lander, and still more rovers and more rovers in the future. But there was a part, I guess, of me that was unsatisfied by that, because it was, as amazing as it is, you get used to, human beings can get used to everything. And landing 3 things on the surface of the Mars was quite enough for me for a career, and the opportunity to contribute to an idea which could actually get humanity into space beyond government funding was something that I thought was worth dedicating myself to.
Exactly. I've thought of your work, and those of NASA, as like Lewis and Clark opening up the Louisiana Purchase. But the people who really opened the West were basically the railroads, which brought planes and so forth.
Exactly, and none of this would be possible without the 53 years of government-funded space exploration and all the discoveries that we have enjoyed thus far. And I think, as we're seeing in the launch business, certainly being able to have commercial operators deliver supplies, and hopefully very soon astronauts and people to wherever they need to go in space, and the idea that we can explore and develop and create industry and create economies. And, I would love to enable an environment where people's job location would be L5 or L1 or some other destination with a P.O. box.
Like Mars.
Exactly.
Indeed. So those are the first steps. Lewis and Clark was a government expedition. And so you see the horizon as being first to do mining. Let's remember that California was opened up mainly by the gold rush of 1848.
Exactly, and the reason Planetary Resources actually founded was on the principle that it has been resources that have opened up every frontier on this planet. And, either it's, I think Neil deGrasse Tyson actually says, fear, greed, and glory are the reasons that cause everything. And, there's probably a love interest in there as well. In the gold rush, there was certainly a lot of people who were going out to make money by the promise of finding gold in the hills, but much of the money was made, of course, by the people who moved out there and settled and made a life. And they would not have been able to do that had California had not had all the other resources that it had, from the timber and the wildlife and the plant life and the land and the sunshine. All those things are things that we take for granted on this planet because they're so abundant. And one of the primary reasons why we're not out there in space living and operating yet is because we've had to take everything that we will ever need for the entire camping trip. We have to take it all to space, including the bottled up oxygen. And every gram of water we want to drink, every pellet of food, and we of course don't make any of that stuff in space. So the ability to go out to the most accessible destination in the solar system off the surface of the planet to a near-Earth asteroid, and start with something as simple as water, something that is the essence of our life, but in space it's radiation shielding from the sun, from the cosmic rays, and you can break it into hydrogen and oxygen using freely available thermal energy and have rocket fuel. And, with that, you can do anything you want, and that's really what excites us.
Exactly. So you've been carrying out more explorations of your own, looking for asteroids to mine. How soon do you think you'll actually go out to an asteroid and do a first prospecting?
Yeah, prospecting is the exact correct word to use. We are what the mining business calls a prospect generator, and we want to find what the first and best asteroid can be to start up, and use thermal processes in space to do everything that we would do, even, for example, mining water off of an asteroid. You wouldn't necessarily need to crush and grind and process and use drilling and complicated processes like that. It's more like distilling seawater, where you heat it up, you bake off the water. It's naturally purified, of course, by turning into a gas. And just like the cycle in your freezer, where all the frost goes to the outside, the water condenses on the coldest spot, and that is your ice mineral that, so long as you keep it out of the sun, you now have pure hydrogen and oxygen in solid form that you can transport to where it's going to be useful.
Exactly. So, do you plan to do the harvesting and the processing right there on the asteroid and bring the products back to low Earth orbit, or what?
Yeah, that's a great question, and one that people ask a lot. Think of a mine on Earth where you drag the mountain to the refinery. And in general, that's not what we do. We try to do as much beneficiation, is the official term for that, as you can, closest to the source, because of course it takes a lot of work, a lot of energy, a lot of fuel, and a lot of cost to move heavy things around. So every mine on the planet has, as a first process, kind of getting rid of all the stuff that's not useful and having some lightly refined process, which you then send back to the refinery. And in the case of water, I think we can get 100% pure water at the mine, and you won't need to do anything else in terms of extracting it. And what you might do in this case is, if you were to use it as rocket fuel, you would keep it in ice right up to the point where you wanted to start filling the tanks of whatever needed the rocket fuel, or maybe in the case of, say, for example, Elon's Mars colony transport, which he's talked about doing in-space refueling on. Maybe you ship up the fuel from the surface of the Earth, whether it's liquid hydrogen or maybe even liquid methane, but the oxygen actually is something that could come from an asteroid, and the oxygen, because of its atomic number, is actually more than 80% of the weight of these liquid fuel systems. So that's a case where, again, you can do most of the purification at the asteroid and leave the asteroid right where you found it, orbiting the sun. You never have to move it. There's no changing its orbit or doing any of those things. You just grab the good parts and leave everything else behind.
What robots are going to do all this work?
So we'll see, I think, a lot of different things. And what I'm excited about, and the reason why I know that this future is sooner than most everybody on the planet thinks, is looking at the pace of innovation and what I would call narrow artificial intelligence, things like Google self-driving cars. Google self-driving cars aren't going to do your homework for you, but they do a fine job of navigating the roads. And be able to extract resources on an asteroid is a relatively narrow and mindless task, I'd actually say. So having things that can operate far away from the Earth in a vacuum in the environment of space is certainly best left for robots. But we'll see things that collect the solar energy. We'll see things that help enclose the asteroid so that as the material comes off of it, we can collect it and condense it. And of course, we'll still see lots of exploration. And this is something that over time, I think it will be very crude and maybe more brute force. And as we do it more and more and we get better at it, we'll see all those things that we read about in the great works of science fiction, where we have all specially adapted little activities where some of them will be separating material A from some material B. Some of them will be moving large amounts of material around different spots, and third robots will be having humans on the other of them helping to repair and fix things. So I think today it's very easy to make the robots that go out and find the resource, and even do the first part of scooping up some material and baking the water out of that material. And what we learn from doing that will guide everything that happens after that.
Are you making the robots yourself, or do you have some way to buy them off a shelf somewhere?
Oh, well, yeah, we're actually, all of our spacecraft, we're making our third spacecraft right down in our clean room right now, and we build almost all of it right here in Redmond and Washington. We buy a lot of the parts, of course, off the shelf, and that's part of the cost savings, is we have looked around the world for all the different pieces of technology, whether it's something that you might find in the control system for your car, or maybe it's something that's used in the medical industry, or maybe even it's an industrial computer where, of course, the market for an industrial computer is much, much more than the number of spacecraft that are made in a year. And we're looking for all those things that we can use and then put together in a way to build our spacecraft that we put into space. And I think over time we'll probably have a lot of partners and a lot of competitors and a lot of customers who will all develop into their own pieces of what will be, as complex of an industry as any industry here on Earth. And like anything over time, it develops from the very simple to the very complex.
Excellent. So what do you see as the big benchmarks to come? And say, what will your business look like in 20 years?
So in 20 years, I think, let's see, what year will that be? That'll be 2035.
2035, yeah.
Yeah, 2035, I think we will easily have been into the era of having multiple outposts in space, some operated by the government, and with our familiar International Space Station, and some operated by private individuals or private companies, either for research, for industry, or maybe even for tourism as a destination for people to go and have that experience. And all of that human activity in space is going to create a demand, which we're going to try to figure out what the best way to fulfill that demand is. And in many cases, the most important resource in space will be people. And those people will need resources. So we should have certainly discovered what are the best sources of water and probably metals in space by the early 2020s. And what's very exciting about this is one good asteroid, it only takes one, has enough materials on it to support an unfathomably large amount of industrial activity in space. And we really could be talking about something that has a mine life of 100 years, until the point where we have as many people living in space as we do on the Earth, and then we'll need more asteroids. And fortunately, there are millions and millions of them. But I think by 2035, asteroid mining and even activities in the surface of the moon with the resources on the moon, and hopefully even the surface of Mars will be something that these resources in space will have allowed us to easily access. And it'll be just an extension of what we've all got comfortable with here on Earth. And I think all of our children and grandchildren at that point will be talking about, gee, what must it have been like, for our parents to have gone through this dramatic transformation from, these human beings that we send in tin cans to the surface of the moon, nearly risking their lives to, enjoying our space sports on the surface of the moon. So yeah. I think that future is easily within our reach, and all the technology that we need to achieve it is here. We just have to find the way to kind of break from the government way of doing things and look at a more entrepreneurial and cost-effective way of doing things.
Exactly. The government doesn't open hotels, but when do you think I might be able to check into Bigelow's hotel in low Earth orbit?
Well, Bigelow, I believe, is going to be putting the beam module on the International Space Station. I'm not sure of the exact date, but I believe it's within the next year. Now, you'd have to buy a ticket from Space Adventures to check out that tour, but I would say the answer to that could be next year.
Excellent, excellent. I've always had an idea, I've used in some of my stories, in fact, of a spherical swimming pool.
Yeah.
In low Earth orbit. You dive in, surface tension can be kept so it doesn't fragment, and you can swim across the pool and pop out. I've always wondered about combining swimming with zero gravity. I'm sure there are going to be a lot of interesting zero gravity sports, too.
Yeah, well, if you've seen the amount of fun that the astronauts have had just playing with particles or water in space, it challenges everything that we know about our environment and how gravity works and up and down. And one thing that I'm passionate about and looking at starting really something to help students understand this is having the lack of gravity be more intuitively familiar. Imagine how every one of our lives would be different if during we spent a week in space and got to learn what it is to float around and to eat and bathe and and play with things. The way that we would approach designing things for space, of course, would be totally different. And it's going to be no end of fun, and I think that's why all of us folks who have got the space bug are so passionate about making this happen, because, who doesn't like having fun?
Exactly. So that's the thrust for Planetary Resources. I've always wondered, though, why don't you call yourselves Interplanetary Resources?
I don't know. It's maybe it's just resources on a planetary scale was the genesis of the name.
Right.
And then we would have to say, well, we should call ourselves Intergalactic Resources, and then we'd be with our local supercluster, and it just all gets complicated.
Right.
So what's in a name?
Many people have observed that the most profound effect of the space program so far may well have been simply the photos looking back at the Earth, to see our Earth as a single entity, as a planet. What do you think will come from the industrialization of near space?
Well, certainly, I think it is in our very nature as humans to climb up to the hill and then look at what we see in the top of that hill, and often the reaction is, oh, I see a horizon out there. I want to go see what's there. So, exploration is within a lot of us. I think another thing that I've come across with people who are very concerned about the industrialization of space is, well, we haven't figured it out here on this planet, and it's caused lots of problems, so we should just stop. And I think that the real answer couldn't be farther from that, in that we have learned all the ways not to do it, and we have an opportunity as we develop space to actually take better care of this planet than any of our ancestors ever have, because we can take aspects that are just a necessary fact of life, of producing energy and producing food and gathering the materials that we need for space, and just being able to really do those not in anyone's backyard, but be able to create an environment where families and societies can thrive and do whatever they need and not worry about a limitation of resources, and instead just contend with an abundance of resources.
Indeed, and the point about space in some ways is that it's the great processor. If you have waste products from smelting platinum metals in future, you can let them ride out on the solar wind and leave the entire solar system.
Absolutely, and I think, in one thing, if I could wave my magic wand and solve any one problem, it would be to create an infinite source of energy. And in engineering, you kind of learn about work and energy and what it takes to do anything, and everything around you in your daily life is defined by a lack of energy, and energy being a very precious thing. And when you realize just how much that defines our lives, if we were able to use resources from asteroids to harness that ball of fusion in the middle of our solar system, there's trillions and trillions of watts hitting the planet every day unused, and 10 to the fifth that amount that's not even hitting any planet, and just going out there into space and lighting up someone's telescope many billions of miles away. So to gather that energy and be able to do anything we want with it, I think can solve most every problem that we're facing in society, whether it's clean water or energy to grow food or transportation, or even dealing with waste and waste management. If we didn't worry about the electric bill, there's lots of technology to solve every one of those problems. So
it's actually an old story. The higher you go, the grander the horizon.
Yeah, we'll soon be dissatisfied with all the limitations that we're experiencing in our solar system, and want to stretch our arms a bit.
Exactly. Well, it's terrific you guys are doing this, and I look forward to seeing your next triumph, and to looking at the first piece of platinum that comes back from an asteroid. That will be indeed an interesting product in itself.
It will redefine probably industry as we know it, and I'm looking forward to that.
Excellent. Well, thanks, Chris Lewicki. That's been a really admirable summary of where your company is going. You have many fans out here, and we're looking for every one of your achievements. And indeed, I'm looking to find out when I can check into the Bigelow Hotel myself.
Yeah, absolutely. And we're really happy to have everyone following the company and contributing what we're doing. And we can't hire everyone on the planet, but that doesn't mean you can't get involved in something that moves all of this forward. So if you don't see someone doing it, take it up yourself and go get it done. So good to talk with you, Greg.
Thank you, Chris.